Luciana went on a road trip. She drove 10 miles in the first hour, 65 miles after the second hour, 120 miles after the third hour, and 175 miles after the fourth hour. If the pattern continues, how many miles will Luciana have driven after 12 hours? Chloe is here with her latest cheat sheet notes. She wants you to know that when you have an arithmetic sequence, you will have the same number added when you go from left to right between consecutive terms, or subtract the same number between consecutive terms if you go right to left. The common difference finds the difference between the two terms. The formula for the common difference is G equals A sub n minus A sub n minus 1. The recursive rule depends on one or more previous terms to generate new terms. That formula is A sub n equals A sub n minus 1 plus d, and the explicit rule does not depend on previous terms to find the nth term. So A sub n equals A sub 1 plus the quantity n minus 1 times d is that formula. Now that we have Chloe's cheat sheet notes, let's go ahead and figure out how far Luciana drove after 12 hours. So first off, I noticed that they gave us the miles that she went every hour, after every hour. So after the first hour, 10 miles. After the second, she went 65 miles. After the third, she went 120 miles. And after the fourth, she went 175 miles. Now, if this is an arithmetic sequence, going from left to right, we would add the same number between consecutive terms, or from going right to left, we would subtract the same number between consecutive terms. So to figure out if this is actually an arithmetic sequence, let's see if we can find the common difference. If the common difference is the same between consecutive terms, all of them, then it definitely is an arithmetic sequence. So the common difference formula is D equals A sub n minus A sub n minus 1. So I'm just going to start with the n, which I have A sub 4. So my n is 4, so that means A sub 4 minus A sub 4 minus 1. A sub 4 minus 1 is actually A sub 3. So when you're finding the common difference, what you're essentially doing is taking one term and subtracting the previous term. So this would be 175 minus 120, which gives me a common difference of 55. That's between A sub 3 and A sub 4. Let's try between A sub 3 and A sub 2. When I do that, I get 120 minus 65, I get 55. And the common difference between A sub 2 and A sub 1 is also 55. So my common difference for this is 55. So this definitely is an arithmetic sequence. Now, if we want to find out after 12 hours how far she's driven, well, we only have after 4 hours. So we could find A sub 5, then A sub 6, A sub 7, A sub 8, A sub 9, A sub 10, A sub 11, and then A sub 12. That is essentially doing the recursive rule. You have to know the previous term, add the common difference, and you get the next term. But I don't want to find A sub 5 all the way through A sub 11. So I'm just going to go ahead and use the explicit rule. This explicit rule does not depend on the previous term. So the formula for this is A sub n equals A sub 1 plus the quantity n minus 1 times our common difference of d. So our A sub 1 is the first term in our sequence, which was a 10. And our d is our common difference, which I substituted with a 55. So we're going to do next is distribute this 55 to each term inside of the parentheses. So we'll have 55 times n and 55 times negative 1. That will give us 55n minus 55. From here, we would combine like terms. 10 minus 55 is negative 45. So our explicit rule is A sub n equals negative 45 plus 55n. Now you can also write the explicit rule. You can switch the terms around. A sub n equals 55n minus 45. They're the same thing. Once you have the explicit rule, you're going to plug in whatever A sub you're looking for. We're looking for A sub 12. So I'm going to plug in 12 for n. So that's 55 times 12 minus 45. So that's 660 minus 45, which is 615. So after 12 hours, Luciana would have driven 615 miles. Again, you could have used the recursive rule and found A sub 5, then added the common difference to get A sub 6, add the common difference to get A sub 7, and so on until you get to A sub 12. But when you have those higher n values, it's easier to use the explicit rule.